if I look at the clock, it's about time for me to start. So I'm going to mute you because I'll do that. And I'm going to pin myself because I do that. And I'm going to get started. Yep, it's time. Well, good afternoon. I almost said good morning. Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry with your host, me, Dr. White. Thank you, Cynthia. And a couple things. First of all, normally on Wednesdays, if we were at ECC, we'd have lecture for 50 minutes, take a 10-minute break, and then we go to lab. Guess what? You're not going to be doing normal labs because you're not going to have chemicals at home. For organic, I wouldn't even do those labs at home. It's not safe. Well, today, if we were having like a normal class and lab, which we will on Wednesdays in the future, what we would do is we go 50 minutes, then we go into the lab. I'd show you the safety video, which is about 40 minutes long. Then I'd do some talking. Then you go in and check in the drawer you have in the lab. It has all the equipment you're supposed to have. I sign off on it and you leave. And on Wednesdays, most of my labs rarely go more than an hour and 20 minutes, even though we have an hour and 50 minutes. So on Wednesdays, you're gonna be getting out early in the future, and today too. Now, since I don't have to show you the safety video because you're not handling chemicals, even though the key things of the safety video is protect your eyes with goggles, which if you were in the lab, you would, and also wear proper clothing, which I make sure you do, and also how to handle chemicals and some basic safety things like never eat in the lab because your food can get contaminated. I'm not going to do that this semester. I've just done that. But with that in mind, what we're going to do today is I'll go the first two 50-minute segments, and then we'll call it a day because we're on track, actually a little bit ahead. All right, couple things. First of all, the YouTube channel is up and running, which I think you already know, and Monday's lecture is on YouTube, and I posted it sometime yesterday afternoon. By the way, I do have a personal request for all of you. Who's ever dreaming of a white Christmas, stop. Wait until next November. I don't know about you, but yesterday I spent some quality time with my driveway snowblower and a shovel. I have a large driveway and the snowplow, because I'm on a bend in the street, I always get a lot in my head of my driveway, but I'd rather have to clean that out than not have clean roads. All right. So that's today's thing. One thing I should mention, we have finished chapter 1, or chapter 2, I'm sorry. We also did whatever you might call chapter 1. Therefore, next Monday, I will go through some of the chapter 2 practice problem questions. And I highly recommend that you do them before I go through them. That way, if you have any questions, you can ask. Remember, in my class, there's no such thing as a dumb question. And also, you'll get the practice and you'll do well. I don't know if I mentioned it. You're not going to learn organic chemistry, do well on a test a couple of days before the test and learn it all. You won't. I couldn't when I was a student. I don't think anybody really can. And therefore, we'll do that on Monday. And don't forget, I mentioned, remember about the bicycle? Watch me do it. It's simple. Wait until you try it on yourself, by yourself alone. It may not be that simple. Also, you'll find out when you do the practice problems, hopefully you have spent time learning the alkanes 1 through 10, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. By the way, you don't have to learn it, but 11 is zundecane, 12 is dodecane, and so on. But anyways, you just have to know 10, and also the important alkyl groups, methyl, ethyl, N-propyl, isopropyl, N-butyl, and tert-butyl, which probably starting next week, I'm going to get lazy and call T-butyl. You can write either on a test. All right, let's go back and just do a little practice because it's good for your grade. Let me just do one thing. And remember, let me get rid of this. We really don't need it. All right. Hopefully all thumbs up, people. You see the whiteboard on there? All right, question would be, what's the IUPAC name for this molecule? I'll let you try that. Oh, first of all, Joshua, you never, ever in my class or any time around me ever say you're sorry for asking a question. Those are always encouraged in my class. And you got a good question. All right, for the practice problems, I do not require them to be handed in. I don't ask any students to do that. What you will be handing in is lab reports, and I'll talk more about it next Wednesday when we have our first lab, and also tests and the final. For practice problems, the way I've done it for many years, this is college. I think I've made it hopefully clear, but I'll say it again. You should do the practice problems. I hope you get a good grade. And I'll leave that on your own. But so does that answer your question? All right, I'll check the syllabus to see why it doesn't open up. I checked it earlier, but I'll check it again. And if it's broken, I'll fix it. It'll be after class today because I don't want to do it now. All right, let's do, and thank you for your questions. Thank everybody for any question you ask in my class or outside of my class. What's the IUPAC name for this? And when you're done, if your video's on, smile. You don't have to, but if you want to, or give me a thumbs up when you're done. I'll tell you what, Joshua, after class today, stick around for a couple minutes, and while you're here, I'll go to D2L and see if I can open it up. And it might be at your end, or it might be with D2L. That's the one nice thing about the way my schedule is. If you have a question or two, I'll stick around a couple minutes after class because I don't have to drive home. I'm already at home. That saves, for teaching at two schools, that saves me about 8 or 9 hours a week driving, which at my age or any age is a good thing. All right, I think everybody's done. Let's do what's the IUPAC, and on a test, what I would have, and the reason I say this is because this way you know what to practice. And say it would be this molecule. Well, first of all, you got to find the longest chain to get the root name. How do we do that? Well, we start numbering. 1, 2, 3, 4, 5, 6. That's one chain. 1, 2, 3, 4. That's the second chain. And finally, I'll go to another color because I can. 1, 2, 3, 4, 5. So the choices are longest chain, 4, 5, or 6. Hopefully I'll pick 6. Oops. So the longest chain is 6. And here's my 6 carbons. And 6 is hexane. And you should know that. Hint, big hint, double big hint. And now notice I have leftover CH3. And you've learned CH3 is your good friend, the methyl group. Are we done? No. What carbon is the methyl group on? You can only start from each end. This would be 1, 2, 3. Starting from here, 1, 2, 3, 4. Which is a smaller number, 3 or 4? Time's up. 3, I hope you all pick. And that would be 3-methyl hexane. Let's do another one. And remember, I think I'm going to make the following announcement because it's time to. Remember, it's your solemn responsibility now that you're in my class to make sure I put the right number of hydrogens down. And if I make a mistake, let me know so I can correct it, please. And again, the question is, give the IUPAC name for the following. They didn't warn you in ratemyprofessor.com. I make you use your brain in my class. See how cruel I am? All right, and I see a few people who weren't here on Monday. And if you missed anything, remember, and I'll show you right after we do this, you can go to my YouTube channel for Chem 170. Bet you didn't know Dr. White was a YouTube star. I'm not. All right, anybody need more time? Going once, twice, let's do it. All right, first of all, oh, look, we have a ring. How many carbons in the ring? 1, 2, 3, 4, 5. 5 carbons is pentane. And it's a ring, and students forget this on test 1. I'm telling you so you don't. For ring, we use the prefix cyclo. So it's cyclopentane. By the way, I have a very bad habit of capitalize things when I shouldn't. But if you do it cap or not, I don't care. All right. So cyclopentane. So immediately that's spoken for. Oh, look, we have 2 alkyl groups. This is an ethyl. This is an isopropyl. 3 carbons. The center carbon is bonded to the ring. Now, IUPAC says, and I'm not holding you to this, so there's actually going to be 4 answers here, but I always do the correct IUPAC one. We have F comes before isopropyl, and therefore this would be 1 ethyl. The carbon chain with their alkyl group with the highest alphabetical priority on a ring is 1. Then this would be, if we count 1, 2, and you go clockwise or counterclockwise to give the lowest numbers to all alkyl groups or substituents. If I go counterclockwise, 1, 2, 3, 4, 5. So now you have to use your high math skills, which is a smaller number, 2 or 5, and 2, I hope you pick. So it'd be 1 ethyl, 2 isopropyl, cyclopentane. Now, if you put the isopropyl first, 2 isopropyl, 1 ethyl, I would still give you full credit. If you put 2 ethyl, 1 isopropyl, even though it's not the IUPAC way, don't tell the IUPAC police I'm telling you this. No, there's no IUPAC police. I would mark it correct. 2 ethyl, 1 isopropyl. And if you also had 1 isopropyl, 2 ethyl cyclopentane, I would mark it correct. Don't forget the cyclo. Students do that. If you don't have that, that would be all wrong. Now, there's another type of nomenclature question I ask on test, and it's also important skill in organic chemistry, and that is, here's a name, what is its structure? A lot of times, instead of draw, I'll put give, and I'll sometimes put condensed, and sometimes I won't, but you should always do the condensed or for Ring's line. And why don't you try this one? Draw the structure for 4-tet-butyl or tert-butyl decane. By the way, I see one of you have a picture of a, I'm not sure if that's a bobcat or a cougar, but Dr. White loves tigers. If you go throughout my home, you'll see some beautiful big posters and pictures I took personally of tigers from the zoo. I actually had a student who spent time in Thailand and showed pictures of real tigers she was with. That was impressive. And as I mentioned, you learn a lot about me in my lectures. It just pops out. The answer is Joshua, no. I did have a friend in high school who had piranhas, and every couple of days, or I forgot how often, he'd feed them live goldfish. We'd all go over and watch them attack and kill the goldfish. But no, I've seen tigers on TV. Hold on 1 second. I'm going to let my answer machine pick that up. One more ring and it'll stop. I was wrong. I counted wrong. Question for the test. Will questions be 3 points? Most of them, yes. That's the way I do it. Quick thing. Not a quick thing. I'll take my time. First of all, my test, if we were in a class lecture or even this VCM, I asked you to take about an hour. In the classroom, we got about 50, 55 minutes. I write tests, so if you've done the practice problems, and do the practice problems. Uh, most students take about 35, 40 minutes. I think I mentioned I teach by my golden rule of teaching. That is, I don't do to my students what I didn't like done to me when I was a student, even though I was one of the better students in my classes, except for English, spelling was not my thing. But uh, I never liked tests where maybe I was the only one who could barely finish and the rest of people didn't. That's not fair. And I try and be fair. Also, it's not fair to have a couple of big point questions. So if you get one wrong, that ruins your grade. I generally have smaller ones. And the questions are like what you see in the practice problems. Don't tell anybody, but after test number one, you'll understand why I call them practice problems. Hint, hint, wink, wink, say no more. By the way, I stole that from Monty Python and the Flying Circus, if you've ever seen that. You're welcome, Joshua. All right, let's get back to our problem. And how do you do this? How do you know what to draw? You start from the right and move left. Decane, you should know, 10 carbons. Now, tert-butyl group is on carbon 4, 1, 2, 3, 4. You could have started from this end. Dr. White might, most of you didn't. And tert-butyl group is this. And it's time for me to do the following. Don't forget, there's 4 bonds to carbon. Yes, 4 bonds to carbon. And now I can put in my hydrogens. I'm going to go at warp drive. And if I make a mistake, somebody let me know. Not done yet, so don't check yet. And that would be the structure of 4-tert-butyl decane. Let's do one more.
Dr. White?
Yes, that's me.
Quick question.
You can do slow ones too.
On the last practice problem, the 4th carbon, there's one bond going from carbon to carbon.
Actually, there are 3. Let's look at this. That's 1, 2, 3. So
okay.
4 minus 3 equals 1, which is why I had 1 hydrogen. If we look at this carbon right here on the T-butyl group, there are 4 groups there. So that's why there's no hydrogen. Let me clean up the mess so you can see it better.
Well, I just
1, 2, 3, 4. Now, when you draw structures, you don't have to put lines in. I like to, one, it helps me, because if I don't, I start doing this. Even I put a line there, I cheated. This keeps my structure straight, and it also helps you count bonds. Okay?
Okay.
And if you need more help, always feel free to come to my office hour or stick around after class, or like you did, ask during the class. All right, you do this one, draw the structure for 1-ethyl, 2,3-dimethyl cyclohexane. Wow, that's a mouthful. Say that 5 times quickly. No, you don't have to. All right, I just tried something and my machine doesn't like shortcut to chat. All right, question was numbering. Do you have to go left to right? And the answer is no. I did it the way you did it. Let me give some more room over here. You could have numbered this 1, 2, hold on 1 second, let me move this. Three, 4, and you could have put the T-butyl group there, make that a 1, make that a 2, and all you're doing is rotating it 180 degrees. In the future, I'm not going to do all ways you can draw it, but I'll do the most common way. Now, hopefully that helped. And the answer is no, it doesn't matter. Molecules like you and me rotate freely in air and in liquids. In a solid, there's very little rotation, but I've never done solid state chemistry. So organic I've ever done has either been gas or liquids, and you have free rotation. Aren't you glad Dr. White's an experienced organic chemist who knows these things? Thank you. And when you're done, give me a thumbs up. Remember, I try and give everybody time to finish. Hurry up, finish. All right. I think everybody's done. Let's do this. All right. How do you decode this to know what to draw? You start from the right, move left. Hexane, 6 carbons. Ooh, cyclohexane. That means I have a ring. Look out, Dr. White's having a great ring drawing day. Now I have methyl. I know that's CH3. Di tells me that's 2. It's on carbons 2 and 3 of the ring. And I have an ethyl group on carbon 1. Now, most of you are going to do this carbon 1. So I'm going to do my ethyl group. Now you can draw the next carbon on this side or this side because there's free rotation around that bond. And most of you are going to put it here. This is carbon 1. Now I'm going to go clockwise because most of you are going to go clockwise, but you could have also gone counterclockwise. And carbon 2, there's a methyl group. Oh, it's your old buddy CH3. And carbon 3, there's a methyl group. Now I could have just as easily done something else. Rotate this 60 degrees. This is the same molecule. It's just like rotating my hands. I could have also, and this is rotating at 180 degrees over center axis. And there are others I could have drawn too. And all I'm really doing is rotating things. If I go like this, oh, look, my left hand. And I say, close your eyes. And I go like, oh, that's something to know. You just rotate 180 degrees. Look, my left hand. Now close your eyes. Oh, look, something. No, you just rotate 90. Or like this, 45, I think that was. Dr. White knows this is a little geometry. And that's how you do it. Now, just to remind you, a couple things I mentioned on Monday. Remember alkanes, where can you find them? Your methane, which is your natural gas, is an alkane. Barbecue, the stuff in the white tank, that's called propane. That's an alkane. Gasoline is about half alkanes or hydrocarbons. If you go and look at baby oil, that's a very long alkane or mixture of long alkane isomers and chain lengths. Reminds me, a number of years ago, I had a student who was coming back to get her master's degree in nursing. And because of the time she had last taken organic, the program she was going to take her master's in nursing, she already had, excuse me, a bachelor's, said you got to take organic again. When I just mentioned baby oil, she had been or was a nurse in neonatal care in hospitals for babies and special babies. And she said, we tell all parents, new parents, that when you're putting baby oil on a baby, don't smoke cigarettes, which you really shouldn't around the baby anyways, and don't have any candles by, because baby oil is almost, not as, but almost as flammable as gasoline. And another one, Vaseline, is even longer chain lengths. And for a while, as I was into what's the mindset, survivalist things, and just interested if I had to leave my house and exist because I had to bug out real quick for 3 days. What do you need? And one of the important things is fire. And one of the tricks to starting fire is have something that will burn easy. And a way to do that and carry it around in your bug out bag. I hope you all have a bug out bag, which is a bag that you can grab right now and leave your home and exist for 3 days. I do. And if you go online, there are different places to tell you what's good bug out bags. One of the things a lot of places tell you, and I understand why, is you take some cotton balls and rub in Vaseline. Vaseline is also very flammable, and that helps you start fires easier. Enough said. By the way, did any of you happen to drive by a gas station and think about gasoline as alkanes, organic chemistry? I hope you do. Remember, organic chemistry is all around you, and it won't hurt to think about it outside my class. All right, I have an important announcement. We finished chapter 2, and guess what? I love my little siren. It's time for a new chapter and new functional groups. Oh, by the way, if you haven't figured out, when I found out, and I do that, I don't bring this in when I teach in class, but I do other funny things. When I get in front of a web camera, I can be a wild and crazy guy. All right, it's new chapter time. And that new chapter, and hopefully everybody sees alkenes and alkynes on your screen. Thumbs up, people. Thank you. And we're going to learn about alkenes and alkynes. And we're going to finally get into the good stuff of organic chemistry. Well, what's an alkene? That's a hydrocarbon, and you should know this, that contains a carbon-carbon double bond. So an alkene, and we show a double bond by a carbon with 2 lines. This is how we show a double bond. If I can spell it right. Dr. White was never good at spelling. And double bond, you should know, has a carbon-carbon double bond. Give me a break. Two more. Is that the last one? One more. I have caller ID. I have no idea who that is. I'm not going to answer it. Anyways, alkenes, carbon-carbon double bond. If we were in class, I'd have it on silent mode, but I'd have to shut off my phone to do that here. I'm not going to. But anyways, alkynes are hydrocarbons that contain a carbon-carbon triple bond. Each line is a bond, and this is a triple bond. Also, each bond, covalent bond, hopefully you remember in general chemistry, it is 2 electrons. So double bond has 4 electrons, triple bond has 6 electrons shared between 2 carbon atoms. Now, I will never ask you on a test, but in case you're wondering, for alkenes, the formula is CN2H2N. For alkynes, the formula is CnH2n minus 2. This I'll never ask on a test, but some entrance exams ask questions. You got an alkene with 5 carbons, how many hydrogens? That's a stupid question. I won't ever ask that on a test. Now, one of the things now that we're getting into the juicy stuff of organic chemistry is that you should ask the question often, why am I learning this stuff? Well, the obvious answer is you want to get a good grade on my test, get a good grade in this class, so you can get into a school or program that makes you take organic chemistry. But really, why should you learn this? Let's find out. Let's look at double bonds. By the way, I'm going to assume the following. I'm going to assume that everybody in my class at one time in your life has seen a carrot. Hopefully you've seen more than one because they're good. Dr. White likes carrots. And you know the color of a carrot is orange. Why is it orange? Well, now I'm going to teach you. There's a molecule called beta-carotene. That's a common name, not an IUPAC, and it has this structure. Now, this is the line structure for both cyclic and acyclic carbons. Every bend in a line is a carbon. Every end in a line is a carbon. And between these 2 carbons, and let me just check. Everybody see that on their screen? Thumbs up, people. Thank you. Are double bonds. So beta-carotene has a lot of carbons, like this right here at the end of the line. This is a methyl group. Same thing here, here, here. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 double bonds. And that's beta-carotene. This is the molecule that causes the carrot to look orange. And now you can impress your friends, neighbors, and loved ones that you can say next time you happen to have a Zoom dinner with them, or if you're at home having dinner and there are carrots in your soup or in your salad, do you know why that carrot is orange? And you can say because of double bonds, beta-carotene. By the way, people, I hate to hear organic chemistry during any meal. Don't do it. But anyways, I learned the hard way. How many of you heard carrots make you see better? Like why Bugs Bunny sees real good. That's because your body, and I'll teach you later on, this molecule breaks the beta-carotene in half to make a molecule called retinol. Retinol, I've heard part of that. It affects your retina in your eye. And carrots do have some effect on your vision. How much? I don't know. Dr. White's an organic chemist, not an optometrist or ophthalmologist or eye surgeon, but I know that much. So let's see, the color of carrots, double bonds. Let's move on. How many of you ever seen a nice ripe tomato? Now that we're in the produce section of the supermarket, and you know it's red. Why is it red? Let's find out. There's a molecule that has the common name lycopene, that has this structure. It's similar to beta-carotene, but without the rings at the end. And notice it's got a lot of carbons and a lot of double bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, it's lucky, 13. 13 has been a lucky number for Dr. White. It has 13 double bonds in it. This molecule absorbs all the light but red, and that's why ripe tomatoes have a red color to them. Let's see. Carrots, tomatoes. I bet you never thought I'd get into that in organic chemistry, but it is. Now, how many of you have ever seen on TV, buy my product to clean your house? It's got a nice lemony smell, fresh lemony smell to it that makes it seem, and wherever you're cleaning, nice lemony fresh. How many of you have ever heard that? Guess what? You've been brainwashed by commercials. In the old days, we used to say Madison Avenue because that's where most of the companies who did commercials were located in New York, but now that's no longer true. You've been brainwashed that a certain scent makes you think, lemony fresh, it's clean. And how did they get that? And also, how about lemons too? There's a molecule that has a common name, limonene. And here's its structure. We have a ring, a methyl group here. This is called an isopropenyl group because it has a double bond in the isopropyl group. So it's no longer isopropyl, isopropenyl. This talks about stereochemistry, which I'll teach you later on. It has 2 double bonds. This molecule comes found in citrus fruits. Organic chemists can make it synthetically too, meaning in a chemical plant. And it's also used in cosmetics, personal care items. When you go, lemony fresh, it's that molecule. If we were in the lab, now I'm going to be sad. When we do a lab on double bonds, I actually have some of that. You get to smell it. Notice I do the right way of smelling it, not going like this. And you'll say, it smells like a lemon. Now you know why they call it limonene, because the original word was founded, it smells like a lemon. So your carrots are orange because of double bonds. Your tomatoes are red because of double bonds. And the smell you smell from citrus fruits are from double bonds. Now, triple bond, in nature, Mother Nature, by the way, I don't know if I told you this, you know who's one of the greatest, if not the greatest of all organic chemists? Mother Nature. Stuff she does is amazing. I'm always in awe of that. However, Mother Nature never did anything, never created a triple bond. That's something organic chemists do. Now, I'll talk about it later. There's certain molecules which we put in triple bonds that have helped change this world. But you got to wait until I talk about it later on. But there is one I can think of, come to think of it. This is called acetylene. Can everybody see it on your screen? And it's got a triple bond, and it's a common name, not the IUPAC. And if you've ever seen a movie where they take that super hot torch to cut out the lock from a safe, or if you've ever been in a body shop for cars, when they have to cut out metal or loosen some bolts on your tires, they use an acetylene torch. And as this is acetylene, it's got a triple bond, and it's an alkyne. So that's double and triple bonds. Now, give you a heads up, one of the things I'll be doing the rest of the good part of the rest of the semester is we'll be having new chapters with new functional groups, which are exciting. And I'll introduce them the same way. I'll show you what the functional group is, like a double bond and a triple bond. Then either I'll go through the nomenclature first, how you name them, and then real world examples, or like today I did real world examples first, because that makes organic chemistry exciting, because it's in our real world, your world and mine. And then afterward, we'll get into the fun part, how to make it and how to react it. But don't forget, I'm a synthetic organic chemist. Synthetic is the fancy word to make chemicals, which is the fun part, but I'm biased. So let's look at alkenes and alkynes. Now, first of all, they're unsaturated hydrocarbons. What does that mean? Well, remember I taught you hydrocarbon, molecule with only carbon, hydrogen atoms, and at least one carbon-carbon double or triple bond. Now, I'll never ask on a test, but you'll see they have less hydrogen atoms than alkanes. That's why they're called unsaturated, because it means you to fully saturate a hydrocarbon, you can't put any more hydrogens in, and you'll learn for unsaturated, I can add more. And I'll show you how this chapter. Now, hydrocarbons that contain one or more carbon-carbon double or triple bonds are the unsaturated hydrocarbons. And this I'll show you later in the chapter. Addition of hydrogen gas, H2, will convert any alkene or alkyne into an alkene. That means you get rid of double or triple bond and turn it into a single bond, carbon-carbon single bond. Oh, I forgot to pull this. Just put an X through this slide. All right, nomenclature. Remember, nomenclature is a fancy word for the naming. Now, the ending ENE is used to designate carbon-carbon double bonds. When more than one, you can cross that off. I should have taken off. It would be diene, two double bonds triene, but we're not going to encounter that. So a double bond. Now I'm going to skip the part with the triple bond and come back to that later on. Now, you're going to do what you did already. When you have a molecule, find the longest chain. But now you find the longest chain that contains both carbons of the double bond. So you're going to look at a molecule and find the longest chain with both carbons of either double, and we'll come back and it turns out triple bond too. And number that from, and I'm going to go through that, you find out, you'll be numbering it. I'm missing something here. I should have something from the end of the chain. So the carbon atoms in the bond has lowest number. Let me show this on an example. And then we're almost out of time, but let's do one real quick. Now, here's a molecule. Everybody see it on your screen? From now on, whenever you look at a molecule, look for what's not a carbon-carbon single bond or carbon or hydrogen atom, because that's where the action and fun always is. Again, whenever you look at a molecule, and I do this instinctively, automatically, I look for what's not a carbon-carbon single bond, ooh, a double bond. And what's not carbon or hydrogen. In this case, the rest are carbon or hydrogen. So, and that should get your attention like that instantly. Just like if you saw red lights behind you in your rear view mirror, it's a fire truck, not the police after you, you will pull over because that's important to know. And this molecule is an alkene, has a carbon-carbon double bond. Now, if I look at the clock, it's just about time to take our break. So let's take a break right now. Come back at 1:55. Come back at 1:55. Dr. White's going to get up and stretch because it helps me. You'll learn that in about 40 years for some of you. And I'll see you at 1:55. a quick test. Do you hear clicking? Give me a thumbs up if you hear clicking. Let's try something. Do you hear clicking now? Let's try. You hear clicking now? You hear it now? Let's try once more. Do you hear it now? Yes or no? You do hear it now? All right, let's try again. Do you hear clicking now? Nope. I think I know what the problem is. I got to redo the lighting over my. Now do you hear it? Do you hear clicking now?
No.
What? Yep.
Oh, a little bit.
Oh, and he is. That means I got to redo the lighting up top of my desk here, which I will over the next couple of days. Well, let me switch to the other camera for now. Hope we can all see me. All right. Let me just do one thing real quick. Look out, it's going to be Dr. White's show and tell time soon. When I was in fourth or fifth grade, we had show and tell. The teachers were afraid, my teacher was afraid of it because they never knew what I'd bring in. And why they were afraid of it was it'd be something science related, chemistry or other, that they had no idea what I was talking about. And they didn't like the class to know they had no idea what I was talking about. All right. We're talking about alkenes, carbon-carbon double bond. Now, let me show you something else about this molecule. How many bonds to carbon? 4. Now, if we look at this carbon right here, the double bond counts as 2. 2 lines, 2 bonds. How many bonds to carbon? 4. 4 minus 2, oh, it's 2. That's why there are 2 hydrogens there. We look at this carbon. How many bonds are there? 1, 2, 3. And 4 minus 3 equals 1. And that's why there's 1 hydrogen there. So remember, double bond counts as 2 bonds to carbon. And you'll learn later on triple bond counts as 3 bonds to carbon. Let me rewrite this. Again, when you look at an organic molecule, look for what's different over the next number of weeks. I'm going to say that often, but that's always one of the most important things in organic chemistry. So the question is, what's the IUPAC name? If I can spell. And first of all, you find the longest chain that has both carbons of the double bond. In this case, 1, 2, 3, 4. Now that's butane. Now, what you do is find the alkane name, butane, and when you see a double bond, you're going to drop the ane ending and replace it with ene. Ending ene tells you an IUPAC name, it's a double bond. Now you'll see some common names that they made up from marketing and sales that has no double bond, but they use it. But for IUPAC, ENE ending, double bond. So now we have butene. Now, I could have put the double bond over here. I didn't. And now you have to say where in the molecule on the longest chain is the double bond. You start counting from the end of the chain that gives the lead carbon, the carbon closest to that end, the lowest number. Here it would be 1. If I started from this side, 1, 2, 3, 4. Or actually, and so 3 would be the lead carbon in blue. So which is the lower number, 1 or 3? Time's up. Hopefully I'll pick 1. Therefore, this is called 1-butene. Again, see the double bond. Oops, I shouldn't have done that because now it looks like a triple bond. See the double bond. Now you know you have an alkene. Find the longest chain with the double bond, 4 carbons, and now we have an alkene. Name that longest chain as an alkane, butane. Drop the ANE and replace it with ENE, and then you need a number. Which carbon is the lead carbon? And why don't you try this one? What would be the IUPAC name for the following? Isn't it nice Dr. White shares the fun? I say fun enough times, you'll believe me. I don't know if I told you this, but IUPAC did such a great job of coming up with these rules for nomenclature, especially organic chemistry. Every molecule has only one individual molecule, separate one, has only one name. Different molecules never share the same name, never. I have never seen an example where that law is violated or rule, and IUPAC did such a great job doing that. It's amazing. All right, anybody need more time? Going once, going twice, let's do it. All right, look at the molecule. Look for what's different. What's not a carbon-carbon single bond or a carbon or hydrogen should get your attention. And if you look here, oh, double bond. And how many carbons are in the longest chain with both carbons of the double bond? And the answer is 1, 2, 3, 4, 5, 6. 6 carbon alkane is hexane. You drop the ANE and replace it with ENE, hexene. ENE ending, double bond. What's the carbon closest to the end of the chain? 1. If I start this way, it would be 6. Hope we all agree it's 1. And that would be 1 hexene. Oh, let's do another one. And you handle alkyl groups the same way you did with alkanes. You number it and name it. And why don't you try this one? What would be the IUPAC name for this molecule? And when you're done, if you don't have your video on webcam, give me a thumbs up. All right, everybody done? I think so. Let's go ahead and do this. All right, look at the molecule. Look for what's different. What's not a carbon-carbon single bond, carbon or hydrogen, get your attention. Ooh, double bond. How many carbons in the longest chain? 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6. You don't count these because you have to have both carbons of the double bond in the longest chain. So the longest chain is 8. 8 for an alkane is octane. But an alkene, a double bond, you drop the ane ending and put in ene, octene. Next, what carbon is the carbon closest to the end of the chain in double bond? Here it's 1, here would be 8. Hopefully you all pick 1. So this is 1 octane. Oh, look, an alkyl group. 2 carbons is ethyl. Hopefully, if you haven't done it by Monday, you'll have learned the alkyl groups table, which is located, there's a file, key alkyl groups, in the lecture section of D2L for you to look at. And what carbon is the ethyl group on? This is 1, this is 2, this is 3, this is 4. You don't count from the other end to check because we've already labeled this carbon 1. And it's on carbon 4, and that would be 4 ethyl 1 octane. And that's how you do nomenclature. For now, I'm going to come back to it in a second. Now, we've done a couple of practice problems. Now, for here, except for one, the switch is off. There's some IUPAC names, and they're common names. Ethylene and is the simplest alkene with 2 carbons, even though this would be ethene, would be that. Propylene would be this alkene. That's the common name. And I'll teach you later this semester that we have a product or product made from the molecule called polyethylene, a polymer, that's made from ethylene. And this poly means many, and there are many ethylene molecules put together to make that product. Same thing with polypropylene. They take many propylene molecules. Now, the one common name I would like you to know, which I already showed you, is acetylene. It's the simplest alkyne. And I could have also written it this way. N carbon on the left can either have a right justified or left justified hydrogen. Notice there are 3 bonds to this carbon, 4 minus 3 equals 1. And that's why there's only 1 hydrogen here. Same thing over there. Now, when I say you should know the common name acetylene, on a test of mine and the final, I will ask questions like either give the IUPAC name or draw the structure. For common names, I'll never ever ask you to give the common name, but what I will ask you to do is draw the structure. Why? Because in things you buy, well, this is water, but things you buy, you'll see a lot of times common names for organic molecules. And guess what? By the end of the semester, you'll be able to know what those are. And that will help you determine, no, I don't want to buy that, or yes, I should buy that because that's in it. I'll teach you about things like things that are antimicrobial and also things that keep mosquitoes away and a whole lot of other things this semester. So these are some of the common names. Now there's one, and I'm not going to ask you to learn it, but I do want to talk about it. If you have 2 carbons with a double bond and it's attached to something, we call this a vinyl group. I'm not going to ask you to learn it. And that's called the vinyl group. How many of you ever heard of vinyl floors? And that's made from molecules with vinyl groups. And that's how it got its common name. And it reminds me, how many of you are old enough to remember the vinyl slip covers for furniture? When I was in high school and grade school, all my parents and all my friends' parents had those in the furniture in their living room. I hated them because if you sat in those in the summer with shorts on or a short sleeve shirt, you stuck to them and getting them off was not fun. Getting up from that couch. Yeah, I've never had anything in my house with vinyl slip covers, but that's a vinyl group. All right. Next couple of slides, click. You can see it better, click. I'm turning the switch. Will it be on the test to the off position? But this is some important background to understand double bonds. So that's why I want to cover it. And other classes, you may need to know about this more depth. Now, when you look at a double bond, and I'm not going to show any hydrogens, you have 2 bonds. They're not the same. One bond is called the sigma bond. This is the Greek letter sigma. The other bond of a double bond, is called a pi bond. And using the Greek letter pi, like the symbol pi. Now, the carbons on here are hybridized. That shows you the orbital diagram. And it has 3 what's called sp2 and 1 p orbital. And because of this, in order to have it, the bond angles of a double bond, unlike a single bond, which is 108, I believe, are 120. And because of the bonds, sigma and pi, there's no free rotation, again, switches off around the carbon-carbon double bond due to the pi bond, which is overlap of the p orbitals. What's he talking about? Let's take a look at a picture. Again, switches off. If we look at this picture, and this is in the book if you bought it, this is a carbon that's in a double bond. And here's the other one. When you bring them together, the ones in a this color, sort of a gold color, are called sp2 hybridized. You have overlap, sharing of each one of these has an electron in it. And this area tells you if you stop time, which I wish I could, but I can't, and you can't either. That's where the probability to find just one electron. And when they share, they overlap. And now you have 2 electrons here. And now the electron in the p orbital of each carbon double bond shares, overlaps, and this is the pi bond. And they're different. They have different energies. And notice here, I have coming out here, this is the bond angle we talk about of 120. Same thing here. And double bond is written like this. Whereas single bond, you don't show stereochemistry. That's what this is called. Switches off. And because of that, a double bond is called trigonal planar. These groups coming from the carbon and the carbon double bond are all in the same plane, the gray color. And orthogonal to that, right angle, is the gold color. And that's, I guess, the yellow. My sisters always yell at me, you don't know your colors. I know red, green, and blue. But anyways, that's where the p orbital would be, the pi bond. Now, did I tell you what a great job IUPAC did? If you have a molecule, it will only have one name. Different molecules never, ever, ever have the same name. I know of no exception to that. Let's go back and look at how to name things when you show the bond angles for double bonds. Let's do 2 examples at the same time. And now I'm showing the bond angle of approximately 120 degrees. And because there's no rotation around a carbon-carbon double bond, these are different molecules. And let's name them. But first, let me just be safe. Everybody see A and B on the screen there? Thumbs up, thank you. All right, if we look at A, now this is carbon 1, 2, I've got my double bond, 3, and 4. Even though this bond angle is like this, 1 is connected to 2, so that's part of the chain, connected to 3, connected to 4. So there's 4 carbons, that's butane. It's a double bond. I'll drop the A and E from butane, A and E, and replace it with butene. Now, what's the lead carbon closest to the end of the chain? Well, if I count this way, it's 1, 2. If I count this way, it's 1, 2. So either way, that's 2-butene. Now, let's look at B. How many carbons? It's got a double bond. How many carbons along this chain? 1 is connected to 2 to 3 to 4. Oh, that's 4 carbons too. And I know that's butane, but it's a double bond. So drop the A and E ending of butane and replace it with E and E ending. And now what's the lead carbon of the double bond? This is 1, this is 2. So that's one way. If I start this way, it'd be 1, 2, and this would be 2-butane. Uh-oh, we got a problem, folks. These are A and B are different molecules because there's no rotation around the carbon-carbon single double bond. These are different. In fact, show and tell time. Here's a model. This is A, this is B. Here's how we show a double bond with the models. And there's no way I can rotate this around to superimpose them. So these are different molecules, A and B. Well, I can't have the same name. Oh no, what do I do? relax. It turns out IUPAC knew about this, and they came up with Cis Trans Isomerism in alkanes. Those are molecules that have the same number of carbons, same hydrogens, in this case in a double bond, and their only difference is around the double bond. Now, cis is same side, and that's for two groups or atoms that are on the same side of a or plane. I'll show you this in a second, of double bond. Trans is opposite sides for two of the same group of carbons of a double bond. So if we go back and look at our examples, if we look at, remember, if I put in a plane right here, notice these two hydrogens are on the opposite side, or same thing, these two methyls. And therefore, this is called trans 2-butene. If I come over here and put that same plane in, and if you had a pen or pencil, lay it down on a piece of paper, and the board, I'd be putting my hand up there now in the classroom. Notice the hydrogens are below that plane, coming out at a right angle, and the methyl group, CH3, are on the same side. And we call that cis. So trans, two atoms, one on each of the carbon that are the same of double bond, or groups too, opposite sides, trans. Two atoms, one on each of the same carbon. When you have a double bond or alkyl groups or carbons, we call that cis. Now, if you look at the examples I've had you do so far before this one, let's look at the very first one I did, where I didn't show the stereochemistry bond angles. And I had, this is 1-butene. Well, how come you didn't have cis or trans? Well, if I put in my, here I have a hydrogen on the same side, and I have this hydrogen on the opposite side. Well, they can't be cis and trans at the same time together. Whenever you have two of the same atom or group on one of the carbons of a double bond, you cannot have cis trans isomerism. Whenever you have two atoms of the same type or groups on the same carbon of the double bond, no cis or trans isomerism, which is why, if you go back and look, all the examples we did before I talked about this, it was always the carbon double bond number one. All right, let's look at an example. And let's look at this molecule. And the question is, give the IUPAC name for the following 3 points each. Well, what do? When you look at a molecule, look for what's different. What's not a carbon-carbon single bond, carbon or hydrogen. Ooh, a double bond. Now we have to find how many carbons in the longest chain with both carbons of the double bond. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. If we all agree 9 is greater than 7, so that would be nonane. Drop the ANE, double bond has a ENE ending. And now, what's the lead carbon of double bond closest to the end? 1, 2, 3. Here it'd be 1, 2, 3, 4, 5, 6. If it was that carbon, which is smaller, 3 or 6, times up. So that's 3 nonene. Now, can you have cis trans isomerism? And the answer is yes. Here's my plane. Notice I have 2 hydrogens on the same side. And therefore, same side is cis. Therefore, this is a cis double bond. Whoops. So this would be cis. Am I done? Oh no, we have our old friend, the methyl group. Now, we've named this carbon right here 3. 1, 2, 3. That'd be 4, 5. This would be carbon 6. So I have a methyl group. Actually, here you don't put a dash. If you did put one, I would never take it off. Is methyl, and it's on carbon 6. So this would be 6-methyl cis 3 nonene. Let me say that again. 6-methyl cis 3 nonene. And that's how you do it. Remember, cis is same side, and this class it's always going to be hydrogens. In real life, it doesn't have to. Now, interesting thing about the late 1980s, early 1990s, I'm not sure. IUPAC said, you know, for some other things, instead of using cis and trans, let's use something different. E and Z. E stands for Engagen, and Z is Zusammen. Engagen is opposite in German, Zusammen is the same. And the organic chemist said, we don't like that. And IUPAC said, well, certain cases it's good to use E and Z. And the organic chemist said, well, we still don't like it. So they kept both in to keep peace with the organic chemists who were complaining, like just about all of us. You have cis and trans, sometimes you'll see in a molecule named E and Z for together and opposite. And why don't you try this one? What would be the IUPAC name for the following molecule? And when you're done, give me a thumbs up. I see some of you already done. I see some of you are not done yet. Again, if you're done, give me a thumbs up. Also, if you're having problems with this, when I first learned this, it took me a while to get used to how to do this. Ask questions, or don't forget, you can always feel free to ask. Come to my office hours. All right, I think everybody's done. Let's take a look at this. When you look at an organic molecule, look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen gets your attention immediately. Double bond. It's an alkene, ENE ending used. How many carbons in the longest chain with the 2 carbons double bond? 1, 2, 3. Even though you show bond angle here, it's still connected. 4, 5 carbons pentane. It's a double bond. Drop the ANE, put ENE, pentene. What's the lead carbon? If I start from this side, 1, 2. If I start from this side, 1, 2, 3. Which is a smaller number, 2 or 3, times up, 2. So this is 2 pentene. Next is the Cis Trans Isomerism. And the answer is yes, because on each carbon of the double bond, we have a hydrogen. And notice they're on opposite sides. Opposite, trans. You don't have to do it on a test in separate color. Let me. And that would be trans 2-pentene. Oh, let's do another one. And why don't you try this one? What would be the name of the IUPAC name for this molecule? Oh, geez. That's a big molecule. Tonight at midnight, I'll be giving speed drawing lessons. No, I won't. Hopefully I'll be sound asleep in my bed by then. I hope so. And when you're done, give me a thumbs up. I see some of you are done. Looks like just about everybody's almost done. All right, I think everybody's done. Let's work on it. All right. Look at a molecule, look for what's different. What's not a carbon-carbon single bond or a carbon or hydrogen should get your, ooh, a double bond immediately, get your attention. How many carbons in the longest chain with both carbons of the double bond? 1, 2, 3, 4, 5, 6, 7. Here I could say 8, or I can go 7, 8, 9. Which is larger, 9 or 8? Hopefully I'll pick 9. 9 is no name. Double bond, drop the ANE ending, put in ENE, nonene. What's the carbon closest to the end of the double end of carbons of the double bond? Going this way, it's carbon 3. Going this way is 1, 2, 3, 4, 5, 6. Which is smaller, 6 or 3? 3. Next, do you have cis trans isomerism possible? And the answer is yes, you do. Notice you have a hydrogen here and here. They're on the same side of this plane going across the double bond, and that is cis. Cis is the same. So cis-3-nonene. Remember, ene ending double bond. We have a methyl group. It's on carbon 7. So this would be 7-methyl. Cis-3-nonene. And that's how, oh, let's do one more of these. By the way, this one you don't have to write down. Again, you don't have to write this. Everybody know what that is? It's transparent. Transparent. You can all boo. That's allowed. Transparent. All right, now let me teach you something about rings and double bonds. And that is when you have a double bond in a ring, it's shown this way. One of the carbons is always 1 and the other is always 2 when you name it. When you have a double bond in a ring and there are no other functional groups, and this class I'm going to stick to this thing's singles functional groups because there are a whole nother level of laws or rules for when you have other combined functional groups. And Dr. White knows those rules, but I'm going to stay away from that in this class because I only have 16 weeks or 17. Also, when you have a ring, and most of the things we'll ever encounter in our life, and the double bond is always cis, and therefore we don't put that in. I think you need a ring of about 20 carbons to have a trans bond in it. I think I saw it once many years ago. Somebody did some research just to show, oh, look what I can do and no one else can do, which is totally worthless, but they did it anyways, and they had a trans double bond. Therefore, how would you name this? Ring, 6 carbons, cyclohexane. Double bond, drop the A on the ending, ene. Since there's nothing else on the ring, I'm done. Now, let's look at this next molecule. What do we have? Look for what's different. A double bond. It's in a ring. How many carbons? 1, 2, 3. Remember, count every bend in a line. Here it was 1, 2, 3, 4, 5, 6 hexane ring, cyclohexane, double bond, cyclohexane. Here, a ring, and that would be cyclopentane. But it's double bond, so you drop the A on the ending, put ene. Now, since one of the carbons, the double bond, is always going to be number 1, you don't put a number which carbon, you don't have to put a number which carbon is the carbon of the double bond. It's always going to be 1. And it's always going to be cis, which this is. Therefore, this I'm going to call 1, this 2, that's 3. That's one way of numbering it. If I go the other way, this is 1, this is 2, because in a double bond ring, one carbon has to be 1, the other has to be 2. Now, if I go in black, numbering it, the ethyl group is on carbon 3. If I go in red, it's on carbon 5. And for alkyl groups, you always do the lowest number. So this would be 3-ethyl cyclopentene. Everybody with me on that? Again, one of the carbons double bond is always 1, the other is always 2. Let me do another one. And the question would be, what's the name of this compound? And here, ooh, double bond in a ring. And therefore, that'd be 6 carbons in a ring, this is cyclohexane. Double bond, drop the A-N-E, put E-N-E. And then if I call this 1, 2, 3, 4, my N-propyl group is on carbon 4. If I go the other way. Now, I did this example and pay attention. The right way is 1, 2, 3, 4, 5. So which is smaller, 4 or 5? And the answer is 4. So the correct answer, this would be 4 N-propyl cyclohexane. Now, I'm going to do in blue a common mistake new students make and don't. They say, oh, I'm going to call this carbon 1. I'll call this 2, 3, and then N-propyl group is on 4. No. See, it even says it on the screen. Why? Because in double bond, the 2 carbons, one always has to be 1, the other always has to be 2, when it's the only functional group in a ring. And this one, it can't be 2. One of these has to be 1, the other 2. And if you notice the ways I did it in black and red, I followed that. And that's how you do it. And since you know Dr. White likes to share the fun, Dr. White's happy because that's one of my favorite alkyl groups. What would be the IUPAC name for that molecule? Oh, Cynthia, I like your emoji. I like mine. Uh-oh, it must be getting late in the day. I've been lecturing all day. Dr. White's getting silly. Oh, one of the things I've been lucky enough to have a great mentors in my life. And through my class, I'll teach you some real life stuff too. And one of the things I should teach you right now is never let go of the little kid inside of you. Never let that person disappear. And inside of me, the 5-year-old when I was is still there and sometimes will pop up and have fun, which is a good thing.
It's not what my wife would say.
Well, I'm not going to argue between. Oh, that reminds me. My sister gave me great advice that I violated once, and it was the biggest mistake I ever made, or big mistake. If you have a friend and his wife, never get in between or take sides. Just I want no part of that and walk away from any argument they're having. You're not a marriage counselor. I one time helped a best friend of mine who's no longer a best friend because he and his wife are having some legal problems. I won't go into. And I said, because I've worked with lawyers, I said to him, you know, when you get a bill from the lawyer, you should check and make sure they didn't pad their time. Some lawyers do that, and he had a lawyer who did that. And his wife got real upset at me that, well, she knew this lawyer. Why am I even anyway insinuating he might not be honest, which he wasn't, but, and she got real upset at me and told my friend, either get rid of your friend or I'm going to divorce you. That's why you never get in between a wife and a husband argument. Never. All right, let's get back to organic chemistry, but don't ever let go of the little kid. All right, how do you name this? Oh, I've got a ring, but I have a double bond. How many carbons in the ring? 1, 2, 3, 4, 5, 6. As cyclohexane. What's the double bond? Drop the A and E, cyclohexene. One of the carbons has to be one of the double bond. You don't put cis or trans, because it's always going to be cis. Everybody knows that. 1, 2, 3. The only other way I could have counted, which is smaller, 3 or 6? The answer is 3. This is Dr. White's one of my favorite groups. I also love isopropyl, and that's the tert or T-butyl. On a test, and starting next week, I'm going to get lazy. All organic chemists call it a T-butyl group. And it's on carbon 3. That'd be 3-tert-butyl cyclohexene. Oh my goodness, if I look at the clock, it's time to say goodbye, because normally we would be in a lab and you'd be checking in right now and you'd be done in about 10 minutes. The first lab, we do check-in, students are always done early. And I'm going to call it quits. We're in a good place. We're right on track. And you will get your full time as if we are in face-to-face. Now, I'm going to say gehen gesund, but before I do that, remember, Monday, I will be going through the Chapter 2 practice problem set. You should do that on your own before I do that, because that way you'll get a better grade, which I think all of you will do want to get a good grade. So also, next week we'll have our first lab. It's going to be fun. I worked out last semester how to do virtual labs. And no, you don't have the same experience moving chemicals, but you have the same thought process, interpreting data and answering questions like if you were in the lab. And it worked out good last semester, and I hope it works out good for you too. Anybody has questions, I'll stick around now. Don't forget, I have my office hours tonight from 6 to 7:15 on Zoom, the other Zoom login. And with that, I'm going to say goodbye, gehen gesund. Remember, that means be healthy in Yiddish. My grandmother used to always say that to me. Great lady, Grandma Greenman, one of the finest people I ever met in my life. Very strong, tough, great woman, smart too. And I'll say gehen gesund, and I'll see you on Monday. Please come.